Today we will discuss quadrupole moment of nucleus, part second. In this part we discuss about the possibilities of charge distribution in the nucleus. So from our previous classes we have derived this formula for quadrupole moment. Here we recall that R is the distance of the volume element from the center of the nucleus, and Z is the Z direction, rho is charge density of volume element, and Q is quadrupole moment, intrinsic quadrupole moment. So the charge distribution exists in the nucleus due to the protons. Since inside the nucleus there are protons and neutrons are neutral, while protons have positive charges. If the coordinate of one such proton are xi, yi and zi, then due to this proton the quadrupole moment will be shown by this equation. And here E is the charge of the proton. Since all protons have equal charges, so there is no mention of EI. Quadrupole moment of the nucleus depends on the symmetry of the charges. Means quadrupole moment, what will be the quadrupole moment? It depends on the symmetry. What type of symmetry of the charge distribution inside the nucleus. So there are three possibilities of charge distribution. One is like this, in which the charge is distributed symmetrically, and second one is this is charge distribution, and second one is the charge distribution in which the charge is stretched along the z direction, and third one is the oblate spheroidal charge distribution. In this, the charge distribution is stretched perpendicular to the z axis. Now if this one is the case, first one is the case, then if this is the center of the nucleus and if here is the volume element, then the distance of this volume element from the center of the nucleus can be written as like this. This one like this one we can write in frame of reference. This one is the point and this distance is r. Coordinate of this is x, y, z. So the distance is x square, y square, z square, root, and we square it, then we get this one. So from this equation we can write this one. Quadrupole moment, if we put this value in this equation first, then Q turn out to be 0. So in the case of spherical symmetric charge distribution, the quadrupole moment of the nucleus is 0. In other words, we can say that if the quadrupole moment of a nucleus is 0, then the charge distribution is spherically symmetrical. Second case, in which the charge distribution is stretched along the z direction, like this one, second one. In this case, the value of this one, 3z square, is greater than r square, since it is stretched along the z direction. So quadrupole moment Q from this equation first, since 3z square is greater than r square, so this one is positive, and Q is positive, then this charge distribution is called Proudhon spheroidal charge distribution. In other words, we can say that if Q is positive, quadrupole moment is positive, then the charge distribution is parallel spheroidal. Third is the case in which charge distribution is distributed perpendicular to the z direction. So in this direction, 3z square is less than r square. Putting this value in equation first, then we can find Q is less than 0. In other words, we can say that if for any nucleus the quadrupole moment is negative, less than 0, then the charge distribution is oblate type. Now we take the unit of quadrupole moment, intrinsic quadrupole moment is barn. Since for measuring unit, the quadrupole moment formula Q is equals to rho r 3z square r square dV. We divide it by the observed value of quadrupole moment. This is charge unit and this one is also charge unit, so this cancels out and the unit remains the unit of area, which means m square, meter square, which is very large for quadrupole moment. Because this is very large, so we take another unit for measuring quadrupole moment and it is called barn. So 1 barn can be written as 10 to the power minus 28 meter square. If we convert it in centimeters, then we can write it 10 to the power minus 24 centimeter square. Thank you.